Oh, good afternoon, everyone, and welcome to this lecture. In this lecture, we are going to deal with electrostatic or electric potential and electric potential difference, and we are going to do some interesting problems on the same. Electric potential, I will just have a quick review of what we had done in the previous class. In the previous class, we have seen the concept of electrostatic potential energy. Electrostatic potential energy comes in any conservative field, work done, does not depend on path. So the change in electrostatic potential energy is negative of the work done. Do we understand this? Remember this? Remember, electrostatic
Yes,
potential
sir.
energy is a scalar quantity, and what? And only the difference is defined. The absolute value is not defined. To find the absolute value of electrostatic potential energy, you have to find a point whose potential can be taken as zero. In most of the cases, that point is taken as infinity. If you divide this change in electrostatic potential energy by the charge which is moving, you get the change in electrostatic potential, or the difference in electrostatic potential Va minus Vb is Ua minus Ub divided by Q. Do we remember this? Yes or no? No, yes. Huh?
Sir.
Then we had seen that electrostatic potential, the SI unit is volt, and we saw the electrostatic potential due to a point charge. Due to a positive point charge, it will be plus kq by r. Due to a negative point charge, it will be minus kq by r. Do we understand this? Remember this? Yes or no?
Yes, sir.
In both of the cases, we have assumed that. We have assumed what? We have assumed that the potential at infinity is zero. Do we understand this? Yes or no? No, yes.
Yes, sir.
Well, we begin our journey today now. With this, let us start with a question, and let me go give you a very quick question, and these are the type of question that you will see. There is a point charge plus q, and there is a point A, and then there is a point B. The distance of point A is r. The distance of point B is 3r. I'll give you 2 or 3 questions that will make you understand the concept of electric potential. First, you have to find out electric field at point A, electric field at point B. I hope you understand the meaning of this symbols. Yes or no?
Yes, sir.
You have to find the potential at point A. You have to find the potential at point B. Remember, I am taking potential at infinity 0. Do we understand this?
Yes, sir.
Then you have to find Va minus Vb, the difference in potential. Point 4, you have to tell me which point is at a higher potential. So I'm giving you all these questions, and I'll give you 2 minutes. Think about them and answer patiently. 2 minutes you have. Yes, bacha, do we have any answer or we are still working on it? Take your time. Don't worry. You just have to understand the concept, and the questions that I have seen coming from this topic are very, very simple. So if you can just understand simple things, you would be doing pretty well in those questions. I'm giving you time. No hurry. We are doing okay course wise. So take your time, understand the question, and give me the answer.
Sir? Sir?
Yes, beta.
Sir, electric field at point A is kq by r square.
Okay.
Electric field at point B is kq by 3r square.
Okay. What is the direction? You have to also tell me the direction. What is the direction of electric field at point A? Point A, it will be like this along this direction.
Yes, sir.
At point B, it will be along this direction. Yes or no?
Yes, sir.
Okay. Chalo. So this is the first answer. Everyone got this answer? Yes or no? Yes or no? Okay. What about the second answer? Potential at point B and potential at point A.
So potential at A equals to plus kq by r.
Potential at point A is
Plus kq by r.
plus KQ by R. Potential at point B
Plus kq by 3r.
plus KQ by 3R. That is also done. Third question. Potential difference VA minus VB. How will you find VA minus VB? Take your time. Tell me the answer. So much time? Why? What is so difficult here? You can't. What is so difficult here, beta? Tell me. Okay, I will do it. VA minus VB. It's just so simple. VA minus VB. Potential at point A is KQ by R. Potential at point B is KQ by 3R. You cannot subtract them. It is taking so much for time for you to subtract.
2kq by 3r.
Oh, why it has taken so much of time, beta? You don't know how to subtract this? What is the problem in subtracting?
No problem, sir.
Why it was taking so long? Anyways, so now we come to the last question. The last question is, which point is at a higher potential? Which point is at a higher potential? This higher potential and lower potential is going to come a lot many times in electric current from now onwards. Which point is at a higher potential? Which point is at a higher potential, which has a higher value? One is KQ by R plus KQ by R, and the other one is
A,
minus.
sir.
Huh?
A.
A, sir. A is at a higher potential. And if you see these electric field lines, they are going from A towards B. The electric field lines are going like this. So it's a very important condition that we can remember. Electric field lines always move from, electric field line always move from or flow from where to where? From
Higher potential to lower potential.
yes, from a point of higher potential to a point of lower potential. Are we paying attention to what we are writing, beta?
Yes, sir.
Have we noted it down, boys?
Yes, sir.
Electric field lines will always flow from a point or always move from a point of higher potential to a point of lower potential. Let me give you one more question. Anyone has noted down that answer?
Yes, sir.
Now comes this question. I have changed the charge and I have made the charge as minus 2q. And then I ask you all the 4 questions. Do you remember all the 4 questions? The 4 questions were find out the electric field at point A and point B, find out the electric potential at point A and point B, find out VA minus VB, and find out, tell me which point is at a higher potential. Can you do it now?
Yes, sir.
Give you 2 minutes to do it. Do it patiently. Take your time.
Sir,
Yes, beta.
sir, electric field at point A is minus 2 kq by r square.
What do you mean by minus? You have forgotten how to find out the electric field? Not a good sign. Not a good sign. It's a very bad sign that you have forgotten how to find out the electric field. Did I ever say electric field minus something?
Sir, it's positive, sir.
So what does the you said minus sign? What does the minus sign mean if it comes? Someone tells you minus or something. What does it mean actually, beta? Electric field is a vector quantity. Remember. So when you say minus, what does it mean? You understand the question?
Yes, sir.
Minus means you are talking about the direction. So you don't have to say it in terms of minus. It's better that you say it in terms of the
Minus
direction.
2
Okay.
kq by r square.
So the magnitude of electric field will be at point A. Electric field will be
2 kq by r square.
2kq by r square. That is the electric field. And what is the direction?
Towards,
Towards where? Towards the point. Do we understand this? Towards the point charge. We understand this?
yes, sir.
Can you give me the answer for electric field at point B?
2 kq by 3 r square.
2kq by 3r whole square, remember. This is the value of electric field at point B. And what will be the direction?
Towards.
It would be like this. Anyone understand this? Yes or no?
Yes, sir.
The next thing is what is the value of potential at point A and potential at point B? Are you ready with your answers?
The potential at point A is minus 2 kq by r.
So remember this. Potential can be positive or potential can be negative. Potential can be positive or potential can be negative. Do you understand this? Yes or no?
Yes, sir.
Okay. So the potential at point A, potential at point A will be minus, oops,
Minus 2
minus
kq by r.
2kq by r. That is the potential at point A. Well done. What about the potential at point B?
Minus 2 kq by 3r.
Minus 2kq by 3r. Everyone is able to understand this? Now you have to tell me the value of VA minus VB, potential difference between the 2 points.
Minus 4 kq by 3r.
So how do you get it? Minus 2kq by 2r. No, sorry, by r. Minus of minus 2kq by 3r. Yes or no?
Yes, sir.
So the final answer is
Minus 4 kq by 3.
minus 4kq by 3r. Now can you tell me which point is at a higher potential, A or B now?
A, sir.
See, bacha, VA minus VB is coming negative. So which point will be at a higher potential? Think about it as maths here, because V is a scalar quantity. VA minus VB is negative. If VA minus VB is positive,
At B, sir.
if VA minus VB is positive, that means VA is greater than VB. if VA minus VB is coming as negative, that means VA is smaller than VB. So which point is at a higher potential here?
B, sir.
B is at a higher potential. Do we understand this?
Yes, sir.
And you see electric field lines are going from,
B to A.
so whether it is a positive charge, whether it is a negative charge, electric field lines will always flow, will always go from a point of where to where.
Higher potential to lower potential.
Do we understand this? Yes or no? No, yes.
Yes, sir.
Pakka?
Yes, sir.
Shall I move ahead in life?
Yes, sir.
Now, this is a question from your previous years, and I hope you can solve this, get the answer, and stay happy. These are the type of simple questions that you expect in an examination hall. I'll give you 2 minutes to solve it. The electric potential at a point in free space due to a charge Q is given as Q into 10 to the power 7 volts. What is the electric field at that point? You have 2 minutes. Think about it and get me the answer. Yes, bacha, are we all trying? We have done so many questions just now. Okay, I'll give you time. Shall I do it for you, bacha? Just now I have done so many questions, beta. Feel confident. You should be able to do this. If you need a help, I'm always there.
Sir, option A.
Sir, option A, is this a question or this is an answer? Option A is correct. Option A is correct. Congratulations, you have scored 4 marks in your NEET. How did you do it? Huh? Any special technique? Or Akkar Wakkar Bombay Bo? You were playing that? So how did we do it? Yes, can you tell me how did you do it? No one knows it. So it is given that electric potential due to a charge Q is given by this. At a distance R, we don't know the distance, so I can just write the formula. Electric potential V due to a charge is 1 by 4 pi epsilon naught K into Q by R. That is given as Q into 10 raised to the power 11 volts. Yes or no?
Yes, sir.
So from here, I can find out the value of R. I can write R as 1 by 4 pi epsilon naught. Q and Q will cancel into 10 raised to the power 11. This is your R. Yes or no?
Yes, sir.
Now I also know the electric field created by this point charge is KQ by R squared. Yes or no?
Yes, sir.
So I just put the value K. The value of K is 1 by 4 pi epsilon naught. The value of Q is Q. I have to multiply it by 1 by R squared. So basically I have to square it 1 by 4 pi epsilon naught into 10 raised to the power 11 squared. Yes or no? Have I done it correctly or have I done it wrongly? Some mistake. Hmm? Have I done it correctly, beta? Or there is a mistake? What is the mistake I have committed? Hmm? Is my answer coming correct or not? It's coming different. Have I done it anything wrong? How did you do? Please tell me.
Sir, R equals to
R equals to what? So what I have done is I have divided it here. I should not have divided it here. I should have multiplied it there. Yes or no?
Yes, sir.
Yes, that was a mistake. So remember, beta, please be careful. You might make stupid mistakes in simple calculations. Don't do that. Once you get this, you should be able to get your answers. Okay? Got this, everyone? So the correct answer is option number A. Do we understand this, everyone?
Yes, sir.
Okay. Shall we move ahead in life?
Yes, sir.
Okay. We move on to the next set of problems, and this is this one. Potential, electrostatic potential due to what should I say? A system of charges, let us say. Due to a system of point charges, let me say. Now, how do you find out the potential if you have more than one point charge? For example, this is a point P in space. Okay. Then there are a lot of charges. Let us say Q1, Q2, Q3, and so on. Now, these charges are going to create their own electric fields. We have seen how do you find out the electric field. We add them vectorally. Now, what you got to see is they are going to create their potential at point P. It will create, let us say, potential V1. This will create potential V2. This will create potential V3. So the total potential at point P will be equal to summation of Vi from I equal to 1 to n. Remember, potential is a scalar quantity. Potential is a scalar quantity, and therefore you can simply add or subtract potential. You don't have to worry about the direction because potential has no direction. Do we understand this, everyone?
Yes, sir.
Yes or no? Okay, so potential is easier to calculate because you just have to add or subtract it just like numbers. Electric field was difficult because you had to also look for the direction of electric field. So let me now give you some problems on this type. Are we ready?
Yes, sir.
Potential due to a system of charges. Let me see if I have a ready-made question here. If I have that, I'll give that first. Else I will make it for you. Okay, first I will make some questions because the question given here would be done later on. So let me make a question here. Okay, this is the question that I'm making. We have got 2-point charges plus Q and minus Q placed, and the distance is given from point O as A. Do you see this?
Yes, sir.
Okay. You have to find the potential at point O and potential at point A. You have to find potential at point O and potential at point A. I'll give you 2 minutes to this. I hope you can do this, yes or no?
Yes, sir.
2 minutes you have. Yes, but anyone with an answer? Shall I do it, bacha? Boys, are you trying? Boys, are you trying the
Sir,
question?
at point of zero.
Yes, bacha.
At point of zero, sir.
At point O is 0. Is that what you're telling me?
Yes.
What about point A? Point O is 0. Okay, I understand. What about point A, bacha? Did you get the answer for point A also? Yes or no? No, yes. Huh?
Sir.
What is the answer for point A? Give you 1 more minute. Girls. What are the girls doing? Chilling out. Don't chill out.
Sir, at point O zero.
At point O 0, late but not so late. Yes. What about point A? Point 0, boys have already given me the answer. I'm more concerned about point A now. Who will give me the answer first for point A? Huh? First.
2 Q by A, sir.
Eh? Looks like I will have to intervene. Okay. Let me first find the potential at point A. Because of this charge, what is the potential at point A? Because of this charge, the potential is K Q by A. Yes or no?
Yes, sir.
And because of this charge, the potential is, we're talking about point O. And because of this charge, the potential is minus KQ by A. Yes or no?
Yes, sir.
So that means the potential at point O becomes 0. 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Do you understand this? Potential at point A is 0. Potential at point O is 0. Do you understand this, everyone?
Yes, sir.
Huh? Boys, girls?
Understood, sir.
Okay. Now let me find out the potential at this yellow point, point A. Let me find out the potential at point A. How do you get the potential at point A? To get the potential at point A, I have to find out this distance. How much is this distance? You have to apply somewhat simple maths. This distance is A, this distance is A. This is a right angle triangle. So this distance will be A root 2, A square plus A square ka root. Do you understand this?
Yes, sir.
Boys, do we understand this? Similarly, this distance will also be equal to A root 2. Yes or no? Now let us talk about the potential at point A because of this pink charge. Because of this pink charge, what is the potential at point A? How much?
KQ by A root 2.
Because of this pink charge, it will be KQ by A root 2. Yes. Now let me find out the potential because of this charge. How much is the potential because of this charge at point A? Huh?
KQ by A root 2.
Minus KQ by A root 2. What do you see? What is the net potential, bacha?
0,
0
sir.
also. So the net potential at point O and A both are 0. Do we understand this?
Yes, sir.
But if you look at the electric field, if I talk about the electric field due to charge Q will be going like this. Yes or no, my dear friends?
Yes, sir.
What will be the value? Tell me the value.
KQ by A square.
Electric field due to the green charge will also go like this. Yes or no? What is the value?
KQ by A square.
Electric field is not 0. If I write the value for electric field at point O, beta, electric field at point O will become 2 times KQ by A square. Yes or no? In this
Yes, sir.
direction. Yes or no? Do we understand this? Every boy and girl, please raise your hand. Do we understand this?
Yes, sir.
That means electric field is at point O is not 0, but the potential is 0. So, from here we understand that if potential at any point is 0, it does not imply that
Or electric field.
electric field is 0. Do we understand this?
Yes, sir.
Potential at any point 0 does not imply that electric field is 0. There could be electric field, but the potential may be 0. Then I can say the reverse of it. I can say the reverse of it. What is the reverse of this? If electric field is 0, It does not imply that, does not imply what?
Electric potential is 0.
It does not imply that electric potential is 0. In fact, it implies that whenever electric field is 0, potential would be constant. And we will see it in the next class how this is possible. Remember these two statements. If potential is 0, it does not imply that electric field is 0. If electric field is 0, it does not imply that the potential is 0. It implies that the potential is going to be constant. Do we understand this?
Yes, sir.
I'll end this class with these two statements. In the next class, we have understood the first statement. We will try to understand the second statement. And we will go ahead with that. With electric potential, first we'll understand electric potential and then we'll move on to electric potential energy. So I'll end this class here. I hope you enjoyed this class. You have the sheet that I've sent for you, yes or no? Practice sheet.
Yes, sir.
Are you trying problems from that sheet?
Yes, sir.
Are you able to do the problems from that sheet?
Yes, sir.
Great. Keep doing those problems and doing the problem in the class, and I'm sure you will be able to solve any problem that comes. So I'll take your leave now. Take care. God bless you all. I'll see you in the next class tomorrow. Bye bye.
Thank you, sir. Bye, sir.
Bye, bacha.
Take care, sir.